Hey, here we go. Rational functions. So remember, rational functions are when we just have a polynomial function being divided by another polynomial function. This is what we call a rational function. All right, so just like we can have an equivalent fraction. So if you remember, an equivalent fraction is just when we have the same kind of amount of the cake cut, we're just cutting it into smaller and smaller pieces. So this is like saying that 1/2 is equivalent to 2/4, which is equivalent to 4/8, which is equivalent to 50/100. All of these represent the same thing. They can all be simplified down to 1/2, but they're just cut into smaller and smaller pieces. Just like we can do that with fractions, we can do that with rational expressions. And to find your equivalent expressions, so maybe my rational expression is 3x plus 1 over 2x. One way to find rational expressions is you just times top and bottom by the same number, whatever number you want it to be. Maybe in this case, I'm going to times top and bottom by 3. So this equivalent expression would be, well, 3 times 3, that's going to give me 9x plus 3. 3 times 2, that's going to give me over 6x. So these are equivalent expressions. I can also do it by simplifying as well. So maybe my original function is 10x y over 5, let's go 15. So I can see here that I have something that I can simplify. I can math frac this. So I can go 10 over 15, math frac, and I can see this simplifies down to 2/3. So an equivalent expression to this would be 2xy over 3. So you can get equivalent expressions by either multiplying or by simplifying, depending on your expression. Speaking of simplifying, when we are simplifying, this just means that I have one term over another term. So for example, I might have x cubed plus 6x squared all over 10x. Okay, so our steps for simplifying is first we want to factor. We only have 2 ways that we can factor. We can take out a greatest common factor, or we have a difference of squares. You always, always, always start with finding the greatest common factor first. Always do that step first. And remember, we do have a button in our calculator to help us find the greatest common factor. So if I go into math, I go over to number. They call it the greatest common divisor, GCD, down here. So if I go 9, I say I want to find the greatest common divisor of 3 and 6. Well, it's 3. So that means I can factor out a 3, and we want to take out the lowest exponent, so I can take out a 3x squared. And remember, it's like we're dividing both of these things by 3x squared. So 3 divided by 3 is 1. X cubed divided by x squared, that's going to leave me with an x. 6 divided by 3, that's going to be a 2. And the x squared is going to cancel with the x squared. Here, I don't have anything to factor, so that denominator is just going to stay 10x. So our next step, our r, we are going to restrict. So these are finding our NPVs, non-permissible values. So remember, our denominator is not allowed to equal 0. So we have to find all of the values that can make our denominator 0 and say, don't equal this. So here I would say that 10x, my denominator is not allowed to equal 0. Divide both sides by 10, so my restriction is x is not allowed to equal 0. Okay, once we have our restriction, then we can simplify. And when we simplify, we always simplify numbers with numbers. We do x's with x's. And if we have them, we do y's with y's or whatever variable we have. So if I want to do numbers with numbers, well, I can try to see, can I simplify 3 and 10? All right, so let's see. So we're going to go 3 divided by 10. We're going to math frac it. Nope, I can't simplify that. So my numbers are going to stay 3. So my numbers are going to stay 3 on top, 10 on the bottom. Then I look at my x's with my x's. So I have an x squared here, I have an x here. So that means this x is going to cancel with one of these ones here. So that x. So this x is going to cancel with one of these. So that's just going to leave me with an x on top. And we can see that this binomial doesn't have anything to cross out with here, because I'd have to cross out this entire bracket. So that means we're going to be left with an x plus 2 on top. So this here is our simplified fraction, or sorry, simplified rational expression. All right. Next stage after simplifying, then we learned how to multiply. Okay, so let's look at an example of that. All right, let's say I have the expression x squared minus 1 all over 3, and I am multiplying that with 6 over x minus 1. So it's a good habit of keeping your binomials in brackets, because then you know that you have to cross out the entire bracket in order to simplify. All right, just like our simplifying, F stands for factor. So we're going to look for those GCFs, greatest common factors, and we're going to look for those difference of squares. So this one has a difference of squares. Remember, a difference of squares just means we have a squared minus b squared, which we find the square root of both of these, square root of b squared, and it comes a plus b, a minus b. So the square root of the first term plus the square root of the second term, and the square root of the first term minus the square root of the second term. You can do the plus or minus in any order, as long as you just have the square roots in there. So if I look at this example here, this is a difference of squares here because x squared is perfect and 1 is perfect. If you want to double check that something is a perfect square, you're just going to put it into your calculator, square root of 1. If it doesn't pop out a decimal, you know it's a perfect square. So this is going to factor down into x plus 1, x minus 1. Obviously, there's nothing to factor out of 3, nothing to factor out of 6, and nothing to factor out of x minus 1. All right, our next step, just like before, we are going to restrict. So we're going to find those NPVs. Again, NPVs are just going to come from the denominator. Obviously, this doesn't have a variable. There's no x here, so I can't find an NPV here. But I can from this one, so we're going to say that x minus 1 is not allowed to equal 0. Add 1 to both sides. X is not allowed to equal 1. Okay, then we are going to get into our actual new step, which is multiply. And in this one, you never distribute, never firework. You only multiply monomials. So things without plus or minus signs. So here I don't actually have anything that I can multiply on the top or anything I can multiply on the bottom. So we just kind of like smoosh the fractions together. I like to write the numbers first. So I'm going to write this as 6, x plus 1, x minus 1. You can see I'm not distributing anything out. Bottom, again, I just like writing the numbers first. And then we can get to our simplify step. Again, we're going to simplify numbers with numbers. So we're going to go 6 divided by 3. We can math frac that. Oh, look, the answer is just 2. So that 2 is going to be in the numerator. There's nothing for this x plus 1 to cancel with, so it's just going to stay x plus 1. And this x minus 1 can cancel with this x minus 1. So this one actually doesn't have a denominator. You can say it has a denominator of 1 if you want. But really, it just simplifies down to 2x plus 1. So again, factor, restrict, multiply. So it might just mean smooshing them together. Don't ever distribute, only multiply your monomials. And then simplify. Okay, adding one more letter to our steps, we are going to move over to dividing. All right, so let's look at a division question. All right, let's look at the steps for dividing. So let's say our question is 7x plus 14 divided by 2x minus 6, and that rational divided by x squared minus 4 all over x minus 2. All right, step 1, like usual, is going to be factor. Okay, and we still only have the two types of factoring. Greatest common factor, and your difference of squares. So this one actually has both. So if I wanted to do greatest common factor, I'm looking here and here. Both of these have a greatest common factor that we can pull out. If I'm doing difference of squares, I'm looking here because x squared is perfect and 4 is perfect. Again, we can double check that 4 is perfect by going the square root of 4 is a whole number. Okay, so if we factor this out, my greatest common factor, again, I can go into here and check between 7 and 14. Well, that's just 7. So I can factor out a 7. 7x divided by 7, that's going to leave me with an x. 14 divided by 7, that's going to leave me with a 2. Here I can see both of these are divisible by 2, so I can factor out a 2. 2x divided by 2 leaves me with an x. Negative 6 divided by 2 leaves me with a negative 3. And we're going to divide that by our difference of squares over here, which square root of x squared is x, square root of 4 is 2, so we're going to have x minus 2, x plus 2. All over this guy doesn't have anything to factor, so we're going to go x minus 2. All right, now we are going to restrict. We're going to find those NPVs. Dividing is special when it comes to your restrictions. You have 3 places that you need to look. we need to look at denominator, denominator, and numerator of the second fraction. We need to restrict all of these. So I need to restrict x minus 3 is not allowed to equal 0. So x is not allowed to equal 3. I have to restrict x minus 2 is not allowed to equal 0. So x is not allowed to equal 2. I can see I've already restricted the x minus 2 here, so I don't have to do it again because it's going to give me the same restriction. But I do have to restrict the x plus 2. So x is not allowed to equal negative 2. So remember, restricting with dividing, we have that extra place that we have to look for our restrictions. All right, then we have KCF. Keep Chewbacca fly, keep change flip, kiss and flip, however you want to remind yourself. So kiss and flip, or I always pronounce it as keep change flip because it tells you your step. So we're going to keep the first rational expression the same. We're going to change the divide into multiply, and we are going to flip the second fraction. Then we're going to do, as it says, we're going to multiply. And remember, you just multiply monomials. We are still never distributing. So again, here I have no monomials to multiply by. So I'm just going to smoosh these all together. So this is going to be 7x plus 2, x minus 2, all over 2, x minus 3, x minus 2, and x plus 2. Which leads us finally to our last step, the one that we know and love, simplify. So we're going to simplify numbers with numbers. Again, we can always double check with our calculator if we're unsure. Nope, I can't simplify this fraction any. So it's going to stay 7 over 2. I can see I have an x plus 2, which can cancel with an x plus 2. I have an x minus 2, which can cancel with an x minus 2. So that just leaves us with an x minus 3 in the denominator. So that is our simplified division. All right, now into the fun ones. So adding and subtracting is when it gets interesting. So remember, when we were adding and subtracting fractions, we always had to have a common denominator. So if I wanted to go 1/3 plus 1/4, I can't add them like this. I had to get that common denominator. So we needed to find the lowest common denominator. In our calculator, this is called the lowest common multiple. So if I go into the math over to that number, you can see I have an LCM here. So if I go 8, I want to find the lowest common multiple of 3 and 4. And it just so happens that that is 12. So we need to ask ourselves, what do I have to multiply each of these denominators by in order to get that lowest common multiple? And whatever I multiply the denominator by, I need to also multiply the numerator by that. So 4 times by what gives me 12? Well, 4 times by 3. 3 times by what gives me 12? Well, 3 times by 4. So this gives me a new question of 1, oops. So this gives me a new question of 4/12 plus 3/12, which now I can add them together. I'm going to keep one numerator, and we're just going to become 7/12. This is the exact same idea when we are adding and subtracting rational expressions. All right, so let's say I have the rational expression. Let's say I have 2x plus 2, and I'm going to add this to let's say 7x. All right. So our steps with these ones kind of similar to multiplying and dividing and simplifying. We do still want to factor, but it's a little different because we only factored the denominator. This one only has one factorable thing. The only thing I can factor is I can factor a 2 out of here. So this is going to become 3 over 2x plus 1. And this guy is going to stay the same. All right, so step 2 is we want to find the lowest common denominator, and then we want to restrict. All right, so our lowest common denominator, when we have numbers in both, we need to find the lowest common multiple of those two numbers. So again, we can use our calculator to help this. Math over to number. I want to find the LCM of 2 and 7. Okay, so my lowest common denominator needs a 14. I can see here I have an x plus 1 on this side, and I have an x here. So my lowest common denominator needs to have one of each of those. So I need to have an x, and I need to have an x plus 1. All right. So what we have to do is we have to figure out, what do I have to multiply each of these denominators by to get it to my lowest common denominator? So if I color code, I can see this has an x plus 1, this has an x plus 1, this needs an x plus 1. So whatever I do to the bottom, I have to do to the top. If I look here, this has an x, this has an x, this needs an x. So I need to multiply top and bottom by x. So this was multiplying by x plus 1. This guy needed an x. Right. And then the last thing that I needed is what could get me to my number. So I need to get to 14. So this one's 7. So I'm going to have to multiply top and bottom by something to get 7 to 14. This one's 2. So I'm going to have to multiply top and bottom by something to get 2 to 14. Well, 2 times by 7 is going to give me 14. And 7 times by 2 is going to give me 14. All right, so let's write this all out. So I have 3 times by 7. Actually, I'm just going to write it all out. So now my numerator, I have an x. I have a 3. I have a 7 all over, well, 2 times by 7, we're going to now have a 14x, x plus 1. That's good. That's what I wanted my lowest common denominator to be. In this one, I have a 2, a 2, and an x plus 1, all over 2 times by 7. That's going to give me a 14x, x plus 1. And that's good. That's what I wanted my denominator to be. So this is now when we leave the denominator alone. Once we find the LCD, we're going to restrict. So I'm going to say that x is not allowed to equal 0 because it's down in the denominator. And I'm going to say x plus 1 is not allowed to equal 0. So x is not allowed to equal -1. Now leave the denominator alone. Focus only on the numerator. So we are going to expand the numerator. And we're going to leave denominator. So this one, I can go 3 times by 7 is 21. So we're going to have 21x plus, well, 2 times by 2 is 4. We're going to distribute that 4 into here. So we're going to have 4x plus 4. And now we're just going to have one copy of the denominator. And our final step is you're going to group like terms. Again, only in the numerator. So we have 21x plus 4x. So we're going to have 25x plus 4 all over 14x, x plus 1. So that's adding. The biggest thing is finding that lowest common denominator and trying to decide how can you get your fractions to look like your lowest common denominator. All right. Solving your equations is a lot like that as well. You'll see that there's a lot of similarities between these two. Okay, so this is the only one where we have an equal sign. So as soon as you see an equal sign, you know you're doing these steps. If you don't see an equal sign, then you have to decide, am I adding, subtracting, dividing, multiplying, or just simplifying? But as soon as you see an equal sign, these are your steps. All right, so let's say our equation here, we're going to have x over x minus 4 plus 3 over x equals 1/2. So you can see, solving equations, you have to have an equal sign. Okay. So, similar to adding and subtracting. First step would be factor denominator. In this case, there's nothing to factor, so we can go to step 2, which is you're going to find your lowest common denominator and restrict. Okay. So you can see I have kind of 3 different denominators here. I have an x minus 4, so that needs to be my lowest common denominator. So I need an x minus 4. I can see I have an x, so my lowest common denominator needs an x. And I have a 2. So my lowest common denominator also needs a 2. All right, so we're going to restrict right from there. So I'm going to say that x minus 4 is not allowed to equal 0. So x is not allowed to equal 4. We're going to say that x is not allowed to equal 0. So there's my restrictions. All right. So when solving, we are now going to multiply absolutely everything by the lowest common divisor. So we are going to, again, this is for solving when we see the equal sign. Multiply everything, every term, by the lowest common denominator. So what that looks like is, again, we have our function x over x minus 4 plus 3 over x equals 1/2. I'm going to take each of these terms and times it by our lowest common denominator. So I'm going to write this a little differently. I'm going to write it as 2x, x minus 4, just because I like to have the monomials in front. So we're going to times this side by 2x, x minus 4. We're going to times this thing by 2x, x minus 4. And we're going to times this by 2x, x minus 4. And from here, we're going to simplify each term. And basically, this is going to help us get rid of the denominator. So after this step, you should no longer have fractions. And the reason that works is because this x minus 4 is going to cancel with this x minus 4. So in this first term, we're left with an x times by 2x. But there's no longer any denominator on that term. This x is going to cancel with this x, so that's going to leave me with a 3 times 2 x minus 4. Again, no longer have a denominator because it got canceled. This 2 is going to cancel with this 2, so we're going to be left with a 1 times by an x times by an x minus 4. So again, at this stage, we should no longer have a denominator. So our last step here is to just solve. In this particular case, quadratic, but it's going to be either a quadratic, or linear equation. So we're going to do just our steps for solving quadratic or linear equations. So that means we're going to multiply everything together. So we're going to times these two things together to get 6. That 6 is going to expand through. Multiplying by 1 doesn't really change anything, so we're going to expand this x through. So x times by 2x is going to give me 2x squared. So 6 times x is going to be 6x. 6 times negative 4 is going to be negative 24. X times x is going to give me x squared minus 4x. As you remember from our prior skills brain dump, solving a quadratic, we need to make everything equal to 0. So I'm going to subtract an x squared from both sides. And I'm going to add a 4x to both sides. That's going to cancel out this side, get us equal to 0. So we're going to have x squared plus 10x minus 24. So we can factor this. We can solve it graphically. We can solve it with the quadratic formula. Again, for all of those specifics, go rewatch the prior skills brain dump. So we need two numbers that add to 10 and multiply to negative 24. Oh, that's going to be 12 and negative 2. 12 and negative 2. So this is going to become x plus 12, x minus 2 equals 0. So set this one equal to 0. X equals negative 12. Set this one equal to 0. X equals 2. For these ones, there is some notes. Always verify. So you're going to sub these numbers back into your original and make sure you get the right answer. So we're going to use our fraction button and we're going to say x. So let's say x is negative 12. So we're going to have negative 12 over negative 12 minus 4 plus, we're going to use our fraction button, 3 over negative 12 equals 1/2. There we go, verified, that one's good. And if we do it again with our other one, x is 2. So we're going to have, again, using our fraction button is the best. So we're going to have 2 over 2 minus 4 plus, again, fraction button, 3 over 2. That one works too. So you always want to verify, and you also want to check against your NPVs. Sometimes because we cancel out our denominators, our NPVs end up as answers down here. And we want to cross it out and say that this is not a solution. It is an extraneous solution. So if you verify and they don't work, first double check your work, check against your NPVs, and then state that it is an extraneous root if it still doesn't work. Whew, that is a long one. I know rationals is one of the harder units in this one, but there you have it.